Hello guys, welcome back to another lecture in this course. In this video, we shall be looking into support vector machine in our supervised machine learning algorithms. In supervised learning algorithms, we have what we call support vector machine. So what is support vector machine? It is a supervised machine learning algorithm that can be used for both classification and regression tasks. It works by finding the hyperplane that best separates the data points into two or more classes. And actually the hyperplane is the line or plane that has the maximum margin between the data points of different classes. And how support vector machine works, it actually works by first finding the support vectors, which are the data points that are closest to the hyperplane. And these points are the most important for determining the position of the hyperplane. And once the support vectors are found, the hyperplane is then calculated to maximize the margin between the support vector of different classes. So let us start by look into support vector machine in Python, and we are going to use our library, which is scikit-learn library. So we need, since we are going to play with numbers, we need to import NumPy, and we need to plot a graph by using matplotlib. And also our support vector machine, we need to use support vector classifier, which is inside the vector machine and the part of the scikit-learn library. And also we are going to use this dataset sample, which is iris. So after loading our iris dataset, we need to split the dataset into features and labels. The x variable here, it takes the iris data and select the first two features. As you can see here, we have a colony and we have two. So we are going to take the first two features here, and which are the sepal length and the sepal width. And the colon in the slicing syntax, it just means all rows. We need all the given rows and the first two columns respectively. So this is what is actually meant by this line of code. And same goes here. Here we are just targeting the iris, the species. So now we need to create our SVM, or our support vector machine classifier here. So we are creating an object or a variable here that we have stored this in. So we have stored it in this variable. Now let us fit the classifier to our trained data. So our classifier dot fit. So we are fitting x and y. Now let us predict the labels for the test data. So to predict here, we are just saying prediction is equals to our classifier dot, we call predict here to predict the x value. And now we need to create the x, the mesh grid. So h here is equals to 0.2, and this just defines the step size of the mesh grid. And the mesh grid is regular grid of points that is used to plot the decision boundaries. And the step size determines the size of the grid cell here. So we said we need 0.02. So we can actually say that here we are having x underscore mean, x underscore max. So here we are just calculating the maximum and the minimum values for our sepal length and the sepal width. And also we can actually say that we have to calculate the prediction class for each point by calling our classifier and predict, and we pass on our NumPy array range for xx value here, which we have created here for this mesh grid with this parameter of the range of the maximum and the minimum that we can see here with our h parameter there. So after doing so, we needed to plot now the decision boundary. So we have to call our pyplot.counter, then we pass on our parameters, as you can see there. Then we need to plot a nature of graph, which is a scatter plot. And on that scatter plot, we needed to label the sepal length and the sepal width. And our title is the support vector machine decision boundary for our iris. Then we run our line of code. And actually we can see that we have three samples or three data sets that we have here. So we are having this side and this side and this side, and this is our boundary, and you can see that some of the data sets are on the other side. So here now we can actually see that the first thing we did was to load our data set, which is a classic machine learning data set that contains data about the sepal and the petal length of 3 different species of iris. And the data set is then split into features like the sepal and the petal length and the labels. And the output of this code is a plot of the SVM decision boundary for the ICIS dataset. The decision boundary separates the 3 different species of flowers, as you can see here. And the application of SVM can be used in variety of classification and regression tasks of its applications. And we have mentioned that the SVM is used on classification of data. If you are classifying data in different categories, and it is used on regression tasks. So for example, in spam filtering, especially on email, handwritten digit recognition, face detection, text classification, medical diagnosis, and financial forecasting, you can use SVM. It classifies things in groups. As you can see here, we manage to apply supervised learning algorithm in classifying the flowers in different categories, in 3 categories, as you can see here. So now also let us load the breast cancer dataset, which is a classic machine learning dataset that contains data about the features of breast cancer tumors. The dataset has 569 rows, each of which represent a tumor. Each row has 30 columns corresponding to the features of the tumor. So if we are to import this dataset, we need to call to load the breast cancer from the dataset, which is our module, which is part of our scikit-learn library. So we load here the breast cancer, and we store it in our variable cancer, and we need to store the data here, which is our independent variables in X, and also the dependent variable, which is our target here. Now, to create the SVM classifier now, we call our class equals to support vector classifier kernel equals to linear. So here we are just saying the kernel is a function that maps the data points to a higher dimensional space. And the linear kernel is the simplest kernel and is used when the data points are linearly separable. So what's left is for us to fit the classifier here of X and Y data that we are having here. After doing so, the remaining is to perform a prediction of the labels for the test data. And remember, we use the X value for the data to perform prediction. And how we are now checking the accuracy, we are using the Y data. So calculate the accuracy. So accuracy is equals to numpy.mean prediction equals to Y. Here now we are saying accuracy dot accuracy. So we are now checking the accuracy of our prediction, and the prediction is the prediction for the X value here in relation with Y. So we can actually see that there is a 96.7% accuracy of the data. So if we are to plot a graph here, for example, let us plot a graph for this, a scatter plot here. Let us run this line of code. So you can actually see that there is an accuracy of this data set. I think this is all for this lesson. Thank you for watching. See you on the next lesson. Bye-bye.